In what ways did they orientate their sacred structures and so forth? We might want to study any or all of these things. But essentially, I'm really looking at how the visual aspects of the world affected what people believed, or how we can come to know those beliefs as well by studying the visual aspects of their world. So what I've actually just represented is basically, not only is it in effective a loop, it's a feedback system, which is both what Heidegger and Husserl always talked about in phenomenology, which we'll touch on in a minute, just really briefly though. So the kinds of things that affected people's visual aspects of their world in relation to astronomy are the nature of the Earth's position in the celestial sphere, for example, the view of the sky, and the spatial illusions that all humans share regardless of their cultural background or their place in time. Essentially, this is how, I'm waiting for Clark to come in on this, but how, in a sense, naked astronomy works. Well, what I mean really by that is when humans look at the sky, what is it that we all can see and that we all share? Okay? So essentially, the study of archaeoastronomy, as we've pointed out before, is understanding what people could see in the world with the naked eye, without instruments. And so essentially, we're researching that concept of interest in naked eye observations of the sky. So essentially, how we understand our world, I want to look at the individual literal perceptions that are basically verifiable through the physical senses, not then how we analyse it, how we come together as a cultural group and go, so what do you think that means, and blah, 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 blah. That happens later. That's your interpretation side. That's when you want to understand belief systems. But to understand belief systems, we have to know what they're really seeing. Okay? So essentially, the first thing that we know is that the solar-based system or world is not perceived by the senses. We don't see the Earth rotate around, I've written the sun, that's nice, around the sun on a daily basis, right? We don't see that. We see something different as individuals, and most animals on the Earth that can observe the sky also see this, and that is that we are standing on this point on the Earth, which is still, and everything revolves around us. You revolve around me, the birds are moving around me, the sea is moving, and all the objects in the sky move around me. I'm my own reference point. So basically, perhaps I'll just say this before I go. So what does this tell us about ourselves and our place in the scheme of things, as everything's revolving around us? Our visions tell us that we exist in the centre of all the different levels of the world. And I use world with a capital W, meaning perhaps we might say universe. For when we observe anything, as I've said, we're centrally positioned. So when we try to understand people's experience of the world in the past, we must consider people's singular place within the entire cosmos, their cosmos, the centre. So basically, as we've got written on the slide here, these experiences are bodily experiences in the most phenomenological sense. They are primordial. They don't need cultural interpretation. Not really. We can argue about that later. And they merge, in a sense, with a human being's pre-theoretical engagement with the world. It's their, basically, literally their perception and their own cognition of that, not a cultural thing that comes in on it. They are pre-interpreted, according to my ideas, obviously. I need to go back one, and it doesn't want to. Okay, I'll just speak that one. So, for those who love philosophy and want to understand the development of thought of what I'm talking about, you can have a look at Edmund Husserl's work. It's called The Original Arc. The original arc, Earth Does Not Move. And it was literally 2 pieces of paper found in an envelope on his desk after he died. And it's very concentrated, it's very interesting. And it really contains and dilutes this concept of how we can understand people as far as he's concerned if we actually adopted the idea of understanding where people think they are in the universe, and it relates that directly to naked eye astronomy. So, ultimately then, it's possible for us to understand something of past people's connection to the sky because we have shared ways of seeing with these people. And these are, as already mentioned, that we think that the Earth and us are the centre of reality, and our brains interpret the world in this way, okay? It is our brains, it's not just our eyes, it's also our brains. We also see, I love this mouse, it's my friend. We also do not see the sky as a half sphere. We all see it as an elongated dome, right? So it looks like that. It doesn't look like this to us. So we know that. And that visual impact also affects, along with other things that I'll talk about in a minute, also affects things like visual illusions where things closer to the horizon look bigger than when they're up higher. But there are many other variables in play with that, and that is, are there big trees next to the horizon? Are there other things? And our senses interact with all of those things in the same, essentially in the same way as human beings. And there's a kind of hierarchical order of the way that they basically, our brain interacts with this hierarchical order of visual cues to which our brains respond. And that's what I say, that we have this primordial way of understanding stuff in the same way that past peoples did. So that gives us an excuse to say, I think we can work out a little bit of what these people are doing. I think we can understand what they see without moving then on to the cultural interpretation. That comes next. Okay. So knowing that, we'll later, that means too, that we can recreate visually what was seen by past peoples, because we do see the same things pretty much. I'm generalising to the average human physiologically. So knowing something of these encounters, these visual encounters, helps us discover what underlay then the behavioural choices or actions of these people in the past, as identified by their material culture, the situation of their monuments, their landscapes, and any other physical traces that we can study. So I've just given you a whirlwind introduction into the kinds of things that, that I see as a basis for studying cultural astronomy, and in particular for myself in prehistoric peoples. And I work primarily in Britain and Iberia, Spain, Portugal, in the West. So today's idea is to introduce you to a software called Horizon, written by Andrew Smith. And what I'm going to do is take you through, with slides firstly, how to set up your computer. So even if you don't have a Windows-based computer, because it only works on Windows, even if you don't know, don't have one here, you can just take notes. I will also send out lecture notes to you. You will have them sent to you after the today, like this evening I'll do that. So you can make some notes about some guidance of what to do. Then I'm going to give a little demonstration with Horizon, and then I'm going to give a really mini example of how I've applied Horizon, using it with Stellarium, but Gail is going to show you how to use Stellarium in a little video. Okay, so let's have a look. So, what does Horizon do? Keep talking about it. Well, the hint is in the name. It really is essentially it can help draw and create apparent elevation profiles of the horizon for a hypothetical observer located at a specific point within the landscape. And that might be, for example, the monument, or standing in front of the monument, or standing where the monument is going to be. I'm standing here because I've determined that this is the place the monument should be, and I'm designing it on the ground. But you, as a researcher, will make the assumption that that person, for example, has stood centrally at the site, for example, and then checked out the landscape and then decided, yes, this is it. But that's a long conversation about that, no doubt, for all kinds of reasons. Now, what the Horizon will do itself is that you put in some topographical data, we'll get onto that, and Horizon will then create the profile by saying, where are you? 1, latitude, longitude. 2, when you're pointed 0.5 a degree away from north, how far is that horizon? How high is that horizon? And it will write, and what is the direction of that point? It will then record it will go through all the, topographical data and create all of that information for 360 degrees. It also includes such things as what's the furthest point a person can see when the sky is, or the atmosphere, is totally clear of all particles and so on. That's up to, depending where you are, but let's say up to a maximum of 100 kilometres. But that's also a debate that people like to have, so there's other debates. But it programs in these considerations. And then it can draw literally either a single line of the horizon in a 2D profile, which we'll have a look at soon in more detail, or it can create a 2.5 complete topographical landscape that surrounds the entire monument or position you're standing. You can use it for other things. So the raw numbers of that date, so basically you're sampling at regular intervals in azimuth, like degrees around the horizon, for the full horizon. The raw numbers of the data create this profile, and they can be saved to a text file for further statistical analysis, which we can go on with at later conversations. So essentially you have this nice horizon profile rendered with azimuth steps. Oh, actually it's 0.01 of a degree, sorry, not 0.05. And runs on a PC. So, what is the horizon? Let's just define it a bit. The horizon is defined as the point with the greatest elevation in a given direction, which an observer would be able to see if the atmosphere was perfectly transparent, though you can alter that within the program. I lost my point. Right. The curvature of the Earth is included, which is very important. And the current version, though, does not include atmospheric refraction when calculating this. So, visibility is usually limited for a few tens of kilometres to up to hundreds of kilometres, and you have to try and have some determination of this under your very specific conditions, because you can alter that distance. And that is, of course, related to light travelling through atmosphere, that light can be absorbed, refracted, and so on. See what else can we have in here. Horizon lets you know things like atmospheric extinction. So stars are brightest usually, we know when they're overhead, and they decrease in brightness as they approach the horizon, because there are star options in there, but not in the same way visually as you can see it with stellarium. I'm pointing Gail, so with stellarium. So there are great landscape features. It shows you the distant mountain ranges. It could show you things like silhouetting of the horizon and so on, but you have to choose very particular options within Horizon itself. So the data is called digital terrain. It's basically a digital terrain data that you'll be putting into Horizon, and you can get that either free off the internet, like for the whole world. There's various websites with them, and we'll show you one soon. Or you might have your own data from, for example, from Britain. I already have some. You have to actually get it converted by Andrew to use it, or come and see me if you're doing Britain, because Andrew's very busy now. So come and speak to me if you need something at 50 metres. 10 metres if you've already got an association with a British university, then I can share that with you. So, for those people who have downloaded Horizon, just let me have a look through and see where we are. So, what can it create? Have a look at that now. Ignore that for a moment. Talk a little bit more about the output horizon. So the top graph is that 2D horizon profile I was telling you about. It shadows in and fills in the area, so you can see the horizon profile very, very easily. I've got my mouse here, is it working? Yes. So there we have the horizon there. Now what is this weird thing at the bottom? This is something we call, it's a logarithmic graph, and across the bottom it shows you the 360 degree, represents the 360 degrees around the horizon. So if you're at north, that's the center. Can you see right at the center end, north? And if I run up my cursor or mouse up to there, it's telling me that at north, on that particular profile, if I run it down, that the horizon is about 0.08 kilometers away from the viewer. Okay, and if we go right over here towards south, we can see it's something like 1.2, and then it's suddenly here just before southwest, it's 18. But we also have that in text in a data file, so you can produce this visually to have a look. And if you've got lots of horizons, like I remember doing for my PhD, of course you should do statistics, but you can also print them all out and lay them around and have a nice look. And it's quite informative. It's very, very useful for doing comparative analysis. But also you can render, as I spoke, but now we can visualize these 360 degrees views of the topographical data of a particular site. This is at this is Loch Buie, a stone circle. And the centre of those two lovely mountains is actually north. So that's another conversation we'll have, where you can discover how people choose very particular landscapes for their monuments. They're also great if you take a 3D, so you've got your 3D landscapes there. That's the bottom two. I'll explain the lines in a moment. But the top one is my panoramic photograph. And you can always do a kind of a check with the software and perhaps the data with your panoramic photographs. But again, if you don't take the photographs on a tripod and convert it appropriately, you won't be able to do the comparisons, because you'll have a horizon that doesn't match up and it's a bit strange. You can't have that evenly. But here we have Loch Buie, and then we have the 3D landscape. So what are those strange lines there? So basically horizon also indicates where, or the paths of particular solar and lunar paths, indicates the particular lunar and solar paths, but also it can do a variety of star paths. What I've labelled on here, for what we've got here, can you see the yellow line just here? This is the rising sun at the summer solstice. And on the other side, this is the setting of the sun at the summer solstice. So, and this is north in the middle, this is south. And here at to the right and the left, you can see the right and the left look the same. You can adjust it, you can adjust the borders to bring it in, or you can have it doubled either side, so it's easier to view when you're just having a look at understanding the paths of the sun and the moon. So this is the sun at the winter solstice. For those of you who are already in the know, the red lines are indicating the paths, the visible paths of the moon closest to or at something called a major lunar standstill. And just to simplify, we can have more correct definitions at a later point, where it's the most southern and northern rising and setting points of the moon that occurs in its cycle. It can often get very, very close to that, but this is the actual most extreme rising and setting points of the moon, and they occur approximately every 18.6 or 0.7 years. And Horizon creates images that look like that. You can ask it to layer those lines on for you so you can observe where these things are occurring. Oh, okay. Put your hand up if you bravely downloaded Horizon last night. Oh, look at you. There's at least one. I'm very proud of you. Well done. Woo! So we all went to Andrew's boring homepage, which only has one link on it. Well done, Andrew. So basically what I had here on the screen was how to do it, because initially we were going to do it all together, but that hasn't turned out, but that's fine. Some of you have done it, and the others will just have to kind of take notes and see how we're going here. So we're already at this point because I set those instructions. So well done. Now, what you have to do is actually just go into your file manager. So those who are doing it at the moment, want you to go into your file manager on C. See where it says main folder. This is your first main folder in C. Make a folder called Horizon Outputs. And then once you've done that, you have to create 2 subfolders within it. And the subfolders are called, we'll just call it Created Landscapes. And the other one is for your 2D data. I have actually run this class before and it works, so that's not we're all going okay. Let me know when you've all done that, because time and all that. Sorry, no pressure. Everyone created your folders? Getting there? Okay, good, well done. I can't see everyone so well. Was there a hand up over here who's got the software?
Downloading on this laptop, and this laptop down battery.
Oh, okay, that's fine. So, okay, I'm going to move on. Everyone's okay there? And don't forget, you'll have these instructions handed to you. Oh, yeah?
I cannot find the Horizon outputs in this folder. Should I create it myself?
Yeah, no, we're creating the folders ourselves.
Oh.
You must create the folders yourself. That's what we're doing right now.
Okay, so outside the application.
Yes, outside the application, exactly as I've written there.
Yes, sorry.
No, that's okay. I probably wasn't clear enough. So, creating your own folders.
The folder 2D data is outside the create landscape. Okay.
Yes. So, one main folder, Horizon Outputs. Subfolder 1A, Created Landscapes. Separate subfolder in separate subfolder is 2D data. I see why you're saying that. Okay, so once you've created the big folder and 1A and 1B, as I've called it, inside 1A, are you ready? Inside 1A, you're going to have another subfolder called 2D Landscapes, and inside that first subfolder, you will have a second one called 3D Landscapes. But don't worry, because even if you don't do it, I'm talking you through it, and you just have an idea that when you go home and practice, you can go, I remember when she said that. And you'll have your notes as well, don't forget, you have your notes. So really, we're just having a little try, and if it doesn't work, don't panic, you can practice. Okay, I'm changing now.
Hang on.
If you want to pair up, don't forget you can sit with someone who has it, maybe help them, whatever. Okay, I'm changing the slide now. Woo. We then have a third folder. We then have a third folder in the main folder, and that's called 3D data. And this is where your 3D landscape data will go. and you can later visually interrogate this within Horizon or separate, and use various tools within Horizon, and that's what I'm going to show you later. And that means that once it's created, because you will name it and label it, once it's created, you will be able to just click on that and reopen it, and you don't have to make the whole thing again, which you'll see soon. This can take some time, like a minute or two. Okay, just to give you information, double-clicking any of the files in folder B or C will automatically invoke Horizon. It will open it, load that file into the viewer image, and then you'll be able to work with that. Oh, here comes the scary part. This is for people who want to use Stellarium. You don't have to do this now, and also it's different for different computers. But basically, if you're going to use your output of those lovely pictures that we're going to make in Horizon, you can then upload them into Stellarium, that fantastic visualization of the sky, video visualization of the sky in the day and the night time. And you need to, though, put some of those landscapes into very particular places so that Stellarium can access them. But all the instructions, again, will be inside the pamphlet that I send you, and it's also inside Andrew's How to Use Horizon booklet. But I just needed to flag that so that you knew that, okay? It's something important that you will want to know about. So you don't have to do that now. We're not going to do that today. We don't have time. That's just to tell you again about Stellarium. I'm going to skip that because we won't have time to do that today, and Gail's going through it with you. But within each folder, there will be very specific files that all look the same. They all have the same names. There's a landscape initiation file. There's a description file which contains its easting and northing, its altitude, and so forth. So one thing I want to say that just a little bit about terminology really quickly, and that is usually I use the word altitude to mean what Andrew has called elevation. And that is basically if you're standing at a horizon, standing at a place and you're looking at the horizon, that angle from where I see to the top of the horizon, that gives you, I would call that the altitude, right? But Andrew has called it elevation, just to let you know. Like that's the height of the horizon according to what you can see. And that's just important for when you're reading this stuff. Right. So what we're going to look at now is how to use some free data off the internet, STRM data, to make a landscape, and then I'll give you a little idea of how you can use that in your projects, and then we'll have a video. So the STRM data is available for free, and you can see here it covers either 30 or 90 metre data on the ground respectively. The quality of this data, of course, is nowhere as good as any national mapping program that anyone has, but it works pretty well for distant horizons. Anything close, like within 50, 30 metres, it's not going to have that, but which can be an issue if you're looking really closely in a landscape archaeology way, or people have affected close horizons deliberately to have a magnificent close view to their monuments, for example, in prehistory. But it's good for practice, okay? It's really good for practice, or where you know you've only got distant horizons. Right. Oh. So what I'm going to show you now are screen grabs of the SRT. I thought it was STRM. Sorry, I've misspelled, written that. The STRM website. This is the website name. I'm going to show you how you can extract data for yourself from there. Okay. So let's have another click. So that's what the website looks like. It's pretty simple and basic. I think they wrote it ages ago because it hasn't changed much over time. And I have just clicked on the I've written it wrongly there too. STRM. Oh, it is SRTM. Oh God, it's just my brain. Okay, I basically see where it's got SRTM data. I've clicked on that, and that's how the page changes. This is the, and I'll just show you the bottom of the page, the same page. It looks like that. And basically your job is, it's a little bit like a game, is to work out which one of those tiles matches the landscape that you need in the world. So it's a lot of click, and then it opens a map. Then it opens a map. It doesn't have the map initially. Oh, that's where I am. So I'm going to look at northwest Scotland, hopefully. And you choose, see those two little yellow squares? The top one is northwest Scotland, and the bottom one, and a little bit of the top of Ireland, and the bottom one is actually Ireland. So I've chosen, that's the data I want from there. And then you hit search, and it downloads it. It shows you this. Actually, finally shows you the map of where it is. And you can see the little blue square here. There's two of them, I haven't got them. That's the top square, that's part of northwest Scotland that I want. And then you can hit, see the writing there, it says download SRTM there. You click that and your data is downloaded. And it comes in a little zip file. And you want to put that folder in your Horizon application folder. For this data, you need to put it in your Horizon application folder. And you can unpack it and extract it there. I've highlighted TIFF because that's basically the one you'll use in Horizon. Hey. Okay. So we're going to actually pop out. I just want to go forward and see how many. Okay, that's the instructions of how to use it. So instead of taking you through it like that, can I get back? Oh no, that's not what we're about. We're going into Horizon. Going into Horizon with my fabulous. So we can just go there. Okay, shall I reduce this as well? Or I'm not worried. No. Stay here. Okay, the first thing we want to do. Oh, okay. We're just going to reshare the whole screen. Okay. So, stay, Gail, stay. Can I just, I'll just read this for a second. Okay, yep. So we're going to do it all in here, right? We're converting the SRTM within Horizon. Yep, that's right. Yep. Sorry. Very. Yeah. Yeah. Sorry. Very tired. Okay. Here we have Horizon's has a really simple, lovely dialog window. It's so nice and simple. So here we have File, Tools, Help. Okay. So we're going to Tools. And what we want to do is to convert the SRTM data into a format that Horizon can use. And Horizon's so great that it will actually convert it for you. So we're going to Tools, File Conversion, SRTM, and our 90 meter data is the 3 arc seconds. So click on that. Yay! And we get a nice dialog window. Now we want to add it. So we're going to add. So that means I'm just searching for where we have put the SRTM data. It's going to be different to where you would have put it. Okay? And Gail is the one that hit it. So I have to let him.
So we are actually, in this drop down, you need to select the GeoTIFF.
So you need to check the TIFF option.
And so we don't take Ireland, we take the other one.
We've chosen the northwest Scotland option.
So we just convert this one. So we say open. And now we have this in the list. Can I add a minute?
Yeah, go.
Just in case your landscape is very large or your point of observation is just on the border of one of these tiles, you can load several tiles and make a combined landscape for that. So in this case, you would have to load a second file. Like if that's on the border, we can load Ireland as well. And we would have several tiles here in this list. But for your application, now we only need one. But here you can select the output directory, so where these pre-processed tiles are really going. Gail recommended one directory, but in this, you are actually free to select your own systematic and just stick to one systematic. I did it in another way. So I placed my data in a GIS folder. Yeah, we just say convert. No, the list is complete in this way.
Okay.
So the conversion takes a minute or so.
Now we have a convert, and you can watch the green lines. Or go and make a cup of tea, usually if you're at home. Walk around a bit, do your exercises, pat your cats, etc. And away it goes. And it will convert it, and once it's converted, it will be in the particular folder that you have chosen. And then we're going to use that specially converted data to create our 2D and 3D landscapes that we can store on our own computer for use later. But also what we'll do first is I'll show you what you can see within Horizon and information you can get from your model whilst you're still within that software. More cat padding and whatever. Spoon results.
So I think good.
Yes, and when the green lines are at the end, even if you see the little bit of light, it should be done. So then we can close that. Then you can just close. Or done. Actually, done is probably better. Don't hit close. Done. Yeah, hit done. Sorry, that was
So
my
first
mistake.
hit done, then you can close this conversion window. And now we are in the main menu, back in the main menu.
Okay. So, when we have not made any Horizon profiles before, we would go to New Calculation. If we had made it before, we go to Load Data File. Okay? Ooh. Is 12 o'clock the end? Ooh. Okay. Yay. Lucky you. Okay, so we're going to New Calculation. And we want to enter our main file. That's the index file. Wow, it's already. Oh yeah, we chose it already, didn't we? We chose it last time.
Could also be the one from yesterday.
Which is the same, right?
It may contain Ireland, but it's the same.
Doesn't matter. Yeah. Okay, so usually what you would do when you don't know your file name and origin, you just, can you see that little box there? It's got 3 dots in it. You would usually click that and then look for it on your computer. You look for the .idx file, because what that is the converted file for Horizon, and that has all the data for that area. And then you would click the name, which would come up in the little line below, and hit open. I'm just going to close that. Okay, so there. Right, you can, we'll leave it like that. So I'm just going to, should I just load?
Yes.
Load. Hit load. Action. It's already loaded. It's supposed to be loaded already because we did it yesterday.
I just loaded.
Yeah, I did.
This goes fast.
Look.
Yes.
Okay, well now we're going to hit start. That was faster than I realized. Now there's a little waiting. So now that we've loaded it up into the Horizon system, it's now basically drawing the map of that whole area in basically 2.5. And I'm just simplifying.
Gail, while we're waiting, just a quick question.
Oh, sorry.
And that is not really that important. I'm just curious.
Yeah.
So this shuttle radar mission data that's from the shuttle doesn't cover all bits of the Earth, like Northern Scandinavia. And
There are parts that aren't there, that's true.
Can a horizon work with other LiDAR data sets, or is that just out of curiosity? If you don't
Yeah, no, the only one that I can offer you is Britain at the moment, not Scandinavia, until I get it converted
I don't
myself.
need it. I'm just curious.
Yeah, for example,
yeah.
Because Andrew used to convert data for people, but he's now moved out of the area
Okay.
and is on other things.
Yeah. Okay.
Yes. We're nearly there.
So
I
you,
should have asked you to bring snacks.
Gail, like you could,
Sorry, Gail wanted to say something.
Actually, we did make it over here.
Oh, did you?
We didn't
We remade it.
we didn't select the viewpoint. It's stored the viewpoint from yesterday.
Oh, that's okay. I want that viewpoint. But we forgot to tell me.
Yes.
Ah. Okay. Good.
question, Gail.
We're going to go back. Yes.
For example, the Australian geoscience LiDAR data for Australian continent, has that ever been converted?
I will speak with the person and get
Okay.
back to you. Yeah.
That would be good.
We're just letting you know that I forgot to tell you how to put your observing point in, because we already had ours in automatic. We already had ours set up. So we're just going to display and get out. You just have to, okay, so don't look, close your eyes everybody. Or not display. Yay, oh, it just died. Okay, I'm just closing that. Do not look.
No, that's fine. Let's go back to the location.
Oh, okay. No, we don't do that. Right. I knew it was the right way around. Shouldn't be listening to you. No. Right. Forget everything I said. So once you've loaded up your data and hit all the buttons that I did say, here we have a fantastic series of, in a sense, dialog boxes. And we're going to ask Horizon to make a very specific topographical landscape or a 2D horizon for us according to the following variables. I want to make one that will include a skyscape from a particular year. I'm choosing 2000 BC. Can you see down here? I could choose. Yeah, but not for prehistoric sites.
You need to select one location first.
Yeah, but wait, I'm here. 20 days. Yeah, then we'll go, yeah, we have to do location, but
That's much more important than
uh,
calendar pages.
Gail was very structured. You can see that I'm a more laissez-faire approach, but eventually we both get there at the end. We want to hit the first tab. But we had to go back to put the location in, right? Remember I was telling you before that what I was saying to them, that we have to go back and put the location in? This is just telling you where the location is.
Yeah.
Sorry people, I'm going to close this temporarily. Yep. Sorry guys, just let me close that for a sec. Okay. Don't panic. Right. Remember this window where I said you have to have your IDX file and load it up? We already had our location set and I did not show you how to do that. So in that window, which was the step before where we're loading up our converted files, you can see dataset, location, DTM calculation. Go to location. Right. Now, in location, you can name the file as you wish. It could be it's actually Standing Stones at Loch Bui, and you put your coordinates in. Now, importantly, with the coordinates, there's a very specific format, but Andrew's handbook shows you exactly how to write them. You can write them in a UTM format, standard meters, east and north. You can write them in a British coordinate system and others. He shows you exactly how to do it. So you don't have to get anxious about how should I set that out. he lays it out for you very clearly on a very particular page about that. And if you say, oh, well, I've written my coordinates, does it look right? I'll just check to see if it's sort of like it should be. Oh, yay, I can see that my little red dot is where my site should be. So if it's off in the sea somewhere, you know you've written it back to front or some other thing like that. And I'll just close that. Oh, it's a mouse. Okay, so we've chosen already a very particular site with its very particular location. I'm not worrying about anything else here. If you did want to, you could, for example, discard very distant data. You could say that I don't want data that's within the first 10 meters or 50. Or you could say, I don't want to see further than a particular distance for whatever your reasons are according to your a priori, that is, decisions you make before you make this landscape. You have to work out exactly what you want. You can also have it, we've got a little bit of a vegetation model here. You have tree lines, and so if you've got tree lines that include snow and all that kind of thing to make it more realistic. Have a tree line load, just for fun. Okay, so now we're going to hit start again. So we've already loaded. I'll just do it again because I like to. So, what's it saying here? Yes, that's fine. Ignore that. So we're drawing it again, but with that location, I just wanted to show you how to put that location in. And again, we wait. And we'll get that other dialogue series of windows up with all those tabs. Thank God for your laptop. Thank you, Gail. Just see if there's anything here that I have to check while we're waiting. Oh no, that's it. Oh, fantastic. So who here, are most of you working in ethnography or living cultures, sorry? Are most of you working in living cultures, or is anybody working in past cultures? Hands up, past cultures. 1, 2, 3. Okay, perhaps I should say past cultures without living cultures. Past cultures without current living, connecting living cultures. I should have said it more like that. So what I mean by that, for example, there is no memory of the making of, for example, the prehistoric monuments in Britain. There's no memory connection with the peoples today in Britain, with the cultures that lived 6,000 years ago. Really? Yeah, yeah.
I thought the Druids did.
No, the Druids are Iron Age. Oh, you're teasing me. You! Out! Okay, here we go. I was recording that. That was good. So good. But just to, because you just look like so like, what? The thing is that apart from that, there have been many, and it's now confirmed genetically, of course, with swathes of people coming in since. The people that live there today have their own mythologies about the sites. So there are people who research people's current connection to the sites today. But it's a very different world, the way that they think and live and the relationship with those monuments. But they interact also with the archaeology and what researchers are coming up with today, and then also weave that into their understanding of their beliefs, or they just make up things according to how they feel when they're at the site. And I don't mean that in a derogative way, but rather their interaction, emotion with places and so on. And then they link up with like-minded people. So there are relationships with sites today, absolutely, but they're not connected in any way with peoples of the past. It's a very different world.
I'm an ethnoarchaeologist, so I'm like,
Yeah, well, but we can talk about that. I knew. Yeah. Okay, display, everybody, display again. Look at that, same as before. So what we can do is we go here and we say, yep, that's our location. We put that on. There's a little red dot on the map. The other interesting thing it can tell you, I don't know why I'm pointing at the screen, maximum ground slope, it can tell you the slope of the ground around the monument and things like that, or your standing point or whatever it is you're looking at. Right, next thing, date, as we were discussing a little bit earlier. So I've chosen 2000 BC here, but actually, more realistically, if I put in about 1400 BC, because these are probably late Bronze Age sites, the circle that is, anything between 1400 BC and about 800 BC. If you want to, if you were looking at more historical sites where you have a sense of, you know, you have a document, this thing was erected in this year, blah, 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 at least the stone was, it might have taken 100 years to build it, but then you can put in other more specific dates here. For example, I'm just going to try and do very simply, how should we create a nice 3D landscape panorama? I don't touch usually any of the what I call default settings. Andrew will discuss these settings in his handbook as to when and how and where you should or shouldn't alter these. You have to really know stuff about your latitude, atmospheric conditions, and all other astronomical stuff. If you're not really au fait, don't touch it. Or you bring in a colleague who knows stuff and you ask them. Terrain, ooh, what do I want it to look like? So I usually just choose natural colours and scale in meters. If you want a snow line, because you know for some places, like if you're in the Highlands of Scotland or you're in the Himalayas or something, you'd enable the snow line. And it's really for visuals, okay? And but I'm not putting in snow line at the moment. Okay, today we're just going to look at the sun and the moon. I'm not going to worry about stars because that is a little bit more complicated, and I know that stellarium is probably more accurate than some horizon stars. Is that right?
Cannot say that.
Okay, we cannot say that. We haven't tested it, okay. But we had some discussion, but pretty good. So I'm going to ask Horizon if it could please put the path of the equinoctial sun, the solstices, and the major standstill. Those are, sorry, it says major standstill, but really it's the path of the moon at its most extreme rising and where most extreme risings and nights. So we'll just click on those. You can choose them. So, yeah, look at that. Click all those. You can choose your colours. You can go through and have fun with that, and also you can choose what kinds of lines you want, just to help it stand out, particularly in publications. It's really nice to have things mixed around luminous and still distance. Again, anything astronomical, default, right? Let's see, display, how do I want it displayed? Right, this will then give you information like, how shall I display my number of degrees around the bottom line? Is it a question or a stretch?
Sorry. What's star map?
Damn you with yourself. I'll just finish that, then we can go back. Yeah. So I really like detail. I want 1 degree grid at the bottom because I love basically analysing the pictures. I want to show azimuths and I want to show my compass directions. I love everything. Let's put everything on. But if you want a clean thing, don't put your declination overlays on. Oh, declination, okay. So just in a really, really, really simple thing, a declination is a value in degrees for the path of an astronomical body. That's very, very simple. It is, of course, more detailed than that, and I'm not going to go into that right now because that's not my lesson today. So it's basically then showing you the number of degrees. So if you've got the sun's path, it will tell you either side of it and on there the number of degrees of that path in declination. It's like its value. So I'm going to not show that. And for Dwayne, he wants to look at star map.
Before you do that, Gail,
Yeah.
vertical stretch for us ethno-astronomers.
Yes, sorry.
Uh,
Yes, okay, yes.
It's very useful for really picking out things that are pretty hard to see on a horizon.
Yes, actually vertical stretch is not working at the moment. Why is that? Maybe it's also optional in another output.
Yeah.
But usually there is a vertical stretch option elsewhere. And basically what that means is if you've got a horizon like Stonehenge, all the way around, you can't see what on earth's going on, but there still might be something on, but you don't know. So you can say, can you please exaggerate the vertical, the visual of the vertical compared to the horizontal, keep the horizontal the same, but increase it by a particular factor, like times 2, times 1.5, and so on. The important thing is that when you're reporting information in your publication, you have to write, I have changed the vertical factor by such and such, so that people know it's not the actual horizon. I'm not sure why that's not working in here. It usually does. We'll see if we can offer it later. Star map. I have not used star map for so long, but it's actually now been blocked out by Andrew. Sorry.
That's an answer.
Not that. Yeah, it's shaded out. Yeah. I shouldn't laugh, sorry. Not funny.
Is it still available?
Star map,
It seems to be disabled.
it's disabled at the moment.
When we click on one of the stars first and then go to start map.
Let's try that. But usually it shouldn't matter, do not matter. We could click on Beetlejuice because that was in our quiz last night. And and basically what it will do when you make your horizon profile or 3D landscape, it will draw just literally the path that object will take in the sky as seen from that side, if you can see it, because you may not be able to see it, okay? And you can choose your colours. So let's see what's going on the star map now. It has been decided.
Have you set the date for the star map? The specific date?
Let's keep things simple for everybody. Sorry, everybody. Everyone gets very keen. All your experienced people, stop it. Okay, going to display. We've done that. We've looked at the number of degrees around the grid. The elevation, I keep that the same. There's rarely anything different to that. That's again that altitude. Okay, remember that I was talking about of the horizon. Horizon can also go down. Okay, below the vertical. That's for another discussion. Leave the viewer mode. I usually put observer at eye level, right? So you can change this. This is saying, where is the viewing point? Do you want to do it? Do you want to draw your thing as according to what it actually is at ground level, or do you want it as a person would see it at eye level? And we've set the eye level somewhere to 1.5 meters. Somewhere around here. Let me just check. Should be here somewhere.
It was in the first computation circle.
Yeah.
Even before.
Yeah, that's right. We said it in the first computation. Sorry. Thank you. Thank God for you. So I want to have it at eye level as a person would be seeing the landscape, because it affects what horizons you can see. You know, where the height of the horizons are. You know, what horizon. Because if I'm down here, excuse me, that means that that chair is blocking what I can see behind it because I'm very low. But if you're up higher, horizons will not be blocking other horizons, but relatively speaking to when I'm on the ground. So choose observer eye level. Okay, so the bitmap box is basically for images, for your 2D and 3D images. The hints in the bitmap. And you can call it what you want. I'm just going to call it Lochbui. That will do. You can have a subtitle if you want to. And then it says image options, overlay. What that's referring to, do you remember that 3D model that I showed you? In fact, we could probably even see it behind here. Oh, that's the secret. I'll show you that later. Okay, let's try that. So remember this model here, and you can see that this is the same as that, So that's about 15 degrees overlap. What that means is that what's on the right-hand side wraps around, it kind of overlaps that section. So I can see the south both in the right and the left-hand side. It's the same horizon. You could do that by just, you could make this without having that repeated on the left and the right. It just helps you follow the rising and setting of the sun and the moon. So I do 15 degrees, but you could do 0. Okay, you can do 0. So we've got that. So there, that's my applications. I'm going to draw in a minute. We'll do that. Bitmap. Now we're going to make the object. Save. No, now I'm going to apply. I'm going to apply all those things that I've chosen. We've chosen all those things. We're going to hit apply. Whoa! Isn't that beautiful data? It doesn't look anything like what we created last night.
Well, you excluded the foreground.
Whoa!
I don't like anything
That's
that's
weird.
closer than so and so.
Yeah, okay. No, that's not how we did it. Well, that shows you what can happen when you're making a thing. Should we open?
Well, you excluded the
Yeah,
first 50 meters or so, and now you're getting this wall.
yeah, okay.
Is this
Oh.
in the creation process?
It shouldn't have been.
You shouldn't have clicked the box.
I didn't. Sorry, okay. I'm just going to have a quick look through here.
No, it's in the first screen.
Really? I don't know.
It's the primary creation screen.
Okay, we'll go back, everybody. We nearly had a beautiful landscape. Just going to close that. Yep.
Close and stop.
No? Yes? Yes. Ah.
Save location.
Oh.
Or continue maybe.
No. It's not.
What's it?
No, enable vegetation. I didn't do anything. There you see? No, I didn't click anything. Okay, that's one of those mysteries that we've had. We redid it. We did it last night and it worked beautifully. So, very sad about that. So I'll have to open the old one. Have you got it on the left?
Well, just the one that we clicked yesterday.
Okay, so where is that?
Hopefully it's still somewhere.
Unless we've overlaid it.
Maybe it worked.
Yeah. We don't know why it did that, and we're mystified because we made one earlier. And unfortunately we've gone over it as well. We don't know why. And I actually had that same problem in class before. Half the students it worked and half the students it didn't, and we all did exactly the same thing. So that's a bit of a disappointment. But the outcome is the same. Okay.
Maybe one of the audience has created
Did anyone
one
create
successfully.
a landscape while we went through?
Long time ago.
No, okay, that's all right. That's all right. Don't worry, these things happen, and all you have to do usually is you have to start again, and I really have no idea what did. Okay, get rid of Ireland. Did we use Ireland last time?
Well, island was inside, but it shouldn't disturb.
Yeah. We're both mystified, and we're both disappointed, but we could stand here and go through the whole thing again while you're just talking amongst yourself, but I think that's not useful. Okay, so what I'm going to do is I'm going to close that, and we're going to pretend we made this. So let's go through. That's a bit disappointing, but essentially what happens is as soon as you've clicked make that, it will open up a viewing window of, I'm going to open, can we see that online now? We're seeing this online, right?
Yeah, you can.
How do I see the slides? That was slightly disappointing because there were things I wanted to show you within Horizon. Thank you. But essentially, as once you've hit that creation button, you hit apply, it will literally draws up and then opens one of these files that you can see here. Oops. Oh, that's interesting. We'll draw it up, and what you can do while it's open in Horizon, you can run your mouse over it left and right, and in the bottom left and right hand side corner of the screen, it will tell you things like what's the number of degrees you are along the horizon, what is the distance, and if you go up to the horizon, what is the altitude, what is the distance from where you're viewing, and you can also zoom right in. It actually, when it opens, it zooms into within about a 20-degree window. And you can feel if you've got a big screen, it's fantastic. And then you use your scroll button and you just scroll, and it's as if you're standing there like this and you're spinning around in the landscape. so that you're seeing it as if you are there, rather than seeing the whole thing shebang like that, because we don't see it like that, do we? No, we see a very particular window. You can make it to a known viewing window, which is about 30 degrees, which includes peripheral vision though, right? And then you can just observe it and put it further away if you want to get more kind of feeling like you're there. And then you can, as I said, scroll, and all this information will come up on the windows below, information on the window below, of what you're looking at, the distances, what it's including, the astronomical phenomena, and so on. So you can actually interact with it within the program. Within the program also, and it's in the instructions, which I think is very, very helpful, is that it shows you how to output the data. So you can output the picture like this, you can output the black and white one that I showed you, but importantly you can also output the data about the orientation, a data file that will have location, orientation as you spin around, distance of the horizon, and the altitude according to where you're looking. And the reason that's helpful is because down the track you might want to compare that information from one site with several other sites which have the same kind of building construction, to try and find out whether people are using the same kinds of landscapes between within a particular building tradition. If you want to know how to do that, you have to come and see me later, because that's another thing altogether. I'm just going to see how much time we've got, because I'm going to show you what we can do. Can someone tell me the time, please?
10 minutes.
8 minutes?
Thank you. Oh, we don't want to go through that again. Okay. So I'm just scrolling through. Ooh, okay. Just very briefly, for about 3 minutes, I'm going to show you a project that I did, and then a video of how I've used Horizon with Cesar. He's the guy that gave the first lecture, and several other colleagues, of how we discovered that there were very particular, or what we discovered rather, that there were very particular relationships between dolmens within northwestern Galicia and the landscape. And then we might talk about and then I'm going to talk about not the orientation of the sites, because that's another whole hour lecture, but I'm going to talk about the importance of the landscapes themselves and the lighting shows that they enabled people, and the way that it interacted with the astronomy, the chosen landscapes. So we had this project, it's by Marie Curie in Europe, and we called this paper Landscapes of the Coast of Death, because they're actually in an area called Costa del Morte, and dolmen topographies in northwestern Galicia. So what these weird pictures are up here is trying to simplify. Perhaps I'll go back. Let's go there. So that's basically the 2D profiles of all the sites in this area, the 2D profiles that we got from Horizon. And if you map them all together, you just go, oh my God, surely there's no pattern. It looks totally mad. It's quite crazy. But we did do an average of that. Can you see the line here? And a standard deviation, like if it was which is a statistical thing I won't go to. Let's just talk about the average shape of the horizon profiles at monuments in Galicia. And what we found here, so see this dark black line there? Average horizon profile of the landscape. Oh, sorry, this is the average, I beg your pardon, I'm quite tired, sorry. This is the average horizon profile of all sites in northwestern Galicia. This is the average profile of the natural landscape just anywhere within this, like random sites, several hundred in this region. And what we wanted to do was to say, have people decided on a very particular landscape that is different from the natural surroundings? Or did they just choose anything and come along and go, yeah? And so we would say, oh no, the site locations according to the horizon profiles are just the same as anywhere in this landscape. But as you can see, obviously they were not. And for all of them, the eastern horizons can see here when we talk about probability, were overall much, much lower, statistically supported, than the surrounding landscapes. And in fact, we had lower horizons in the east, higher horizons in the west, which is the exact opposite to the majority of locations in this area. And then, when we chose sites that actually also had the furthest horizon towards the east, in the direction of the orientation of the corridors, I might add, every single part of the horizon, except one blip, were significantly different to the random locations within this area. So that meant that they chose very specific horizon shapes for their dolmens. So what was, and you can actually see it in the landscape, by the way. When I was doing field work, I mean, there's a ridge over there. Another side. Hey, there's a ridge just like the other side. So we thought we better do something about that as well. But what was really interesting about these sites is that, these ridges, sorry, is that, can you see the black lines? The black lines on the outer side here, this is the rising sun at the summer solstice. This is the rising sun at the winter solstice. This is the setting. So essentially all the rising and settings of the sun were contained on the ridges on average. The red lines are the risings and settings of the moon at the most extreme time in its cycle, the most extreme rising and settings in its cycle. So essentially they were containing all the rising and settings of the sun and the moon where possible on these ridges that they made sure were in the east and in the west. And this was as, yeah, and I just thought that was astounding. I remember running up the corridor to Tessa going, oh my God, look at this, look at this. And so here are now the 3D versions of these landscapes, just to show you the topography. And again, the red is the moon, the yellow is the sun, the central one is the equinox. Just to give you a visual. 5 minutes, thanks.
No, that was me asking a question.
Oh, question, sorry. What question?
I do too.
I can't tell the difference. So one of the things that came,
That means I get extra 2 minutes.
we got an hour and a half for lunch, we're okay.
Yeah.
One of the things that came up when I was working on some similar projects with some grad students is whether if we were to do a selection of, say we had 10 sites we're going to analyze, or 20, whatever, and we would do 20 random ones, we kind of have a bit of a random generator, put spots in there. Did those random spots have the same kinds of profiles?
No.
So there's a way of testing that. So
Yes.
is that something that's been done?
Sorry, that was clearly a bad description that I didn't say that clearly enough. Yes, but so this here is are the random profile, are the profiles, average profiles of the random sites in the region. And I'm sorry if I didn't clarify that, but thank you for that. Yes, so, and they are statistically significantly different, the monument landscapes, to these random sites.
Great, also 2 minutes.
No, sorry, bad.
But that very much follows the sort of approach we did in Western Scotland like
Yeah.
40 years ago, and you've redone some of that work, haven't you?
That's right, yes,
Yeah.
tried to.
And-
but we've also tried different statistics to see
Yeah.
how that works, and actually looking at the entire horizon, like the 360-degree horizon. And, whereas I know that you did an enormous amount of field work and having to focus very much on the horizons close to the orientation.
Yeah, that was our approach.
That's
which,
right,
And you
so-
moved that on by doing this 360 degree
Yeah,
approach.
exactly. So
Yeah.
they had been looking very much at the orientations and the horizons just either side of those orientations to see if they were significant, quite broad, but also in some other locations as well. So,
But that
later
idea of
maybe
positions
more.
in the landscape, when we moved on from that to the particular work in Mull, that was exactly what we were doing, looking at positions in the landscape,
yes,
because we were finding, they weren't just in places that had a huge, distant horizon all round, but they seemed to be preferentially in places where you had a distant view of a certain mountain and the moon, but generally restricted views elsewhere.
exactly.
But again, that didn't apply to random locations.
That's exactly right. And in fact, you
you've
see,
seen that too, haven't you?
yes, Exactly. They tend to be quite little, nicer amphitheatres. Sometimes they're huge, and other times they're very cosy amphitheatres like this, and then the sea view in one, or lake, and then.
If I read that correct, so the orientation of the dolmens was to north.
No, I haven't done anything about orientations. Not speaking about orientations at all yet. The only thing I've talked about orientations is that they were in the east. So this is just the landscape and the way the sky and the landscape are viewed have been selected.
So if you're standing at the site,
Exactly.
that's,
Yes.
okay, I understand.
So basically the monument is centrally placed here.
Yep.
And so they've chosen landscape and set it up specifically for Dom. Orientations are another story. But we can talk about that.
Yeah, just a comment about, in fact, you have a correlation among certain kind of landscapes and the selection of sites. But we don't know really if the kind of landscapes are the reason for the selection.
Well,
Because, for example, you can find that the people choose the place with another reason that
Yes.
have a causal connection with the landscape, but it's not by the landscape. For example, we choose a place that is in the river valley,
yes,
and this coincides because of the region and the topography
yes,
with some kind of profile of landscape in one side and another. But
absolutely.
we don't care about it.
Sure, sure.
But the thing is that the thing about northwestern Galicia is that it's all river valley. The whole thing, there's thousands of rivers just in a time, thousands of small rivers all the way through Galicia. And the monuments aren't in all the river valleys.
It's only an example.
Yeah. I'm just saying, for example,
Yeah.
I know what you're saying, but the thing is that then we went on with the astronomy, right? And then, so it kind of locks in with the orientations, with the statistical testing of the orientations, which could not occur unless you had horizons of a particular altitude. You can't
You're
statistically.
picking a correlation
Yeah.
and showing that correlation exists and may have been significant, but of course what you're not showing is all the
Yeah.
other correlations
Yes.
that may also have been significant.
Yes.
Yeah. But
I
you know,
agree
you're
with
aware
that.
of that restriction. Sure.
Yeah.
Yeah.
Yeah, no, I don't disagree with that in principle, but that's why then you keep going, well, what else is there?
Yeah.
Yeah, I think that's a very good point. But then, it's very, very hard. So unless, even though Clive totally disagrees with me, and has said so several times, I do think that erecting monuments is a kind of a feng shui things going on. It'll attack me later. But like when we were at the two in China, in southern China, they're going, the Tiger Mountain has to be there, and that's the Saddle Mountain has to be in the front, and water has to be in the front, and it has to be in the south, and this other kind of mountain, Saddle Mountain, has to be there. They had all these descriptions. So when I was doing my stuff on Marlin, this stuff, it's like, there has to be a mountain like that in the north and a northwest, and there has to be one in the northeast, and there has to be water in the south. And there was the whole same, like there were tons of variables, and they were all the same across sites. And so I kind of feel that there's all these important reasons for sites being there, and it's always more than one. You have to have, like you said, a river or other things. But
To be continued.
To be continued. Yeah. So sorry, people. So let's move on. Okay. Yep. So just finish that. Okay, but there are other things going on. So I did this kind of thing called the art of dimensional space, and what we were looking at was the effects of lighting of astronomical phenomena at sites because of the way they've chosen their landscape horizon shapes. So, for example, this site is oriented towards a certain point of the just south of the east. This is east. Sorry, this is east. We've done statistical tests on the orientations. Okay, so that's enough proof, support, all that kind of thing. So this site is orientated to the sun just here. And this is on the exact day where the sun comes up at this exact orientation. Obviously, it could be a little bit this way or that way. We did the central point of the orientation. And on this day, and days just either side, when you have the sun rising in the direction of the monument, or within a few days either side, as the sun comes up, the first stage, which we don't have here, is there's a glow just along the horizon line itself. It says here, this horizon in the direction of the orientation of the monument. This ridge is significant, okay? This ridge, which contains all the rising and settings of the sun and the moon at this site, here it is. And you'll find that as you go through the day, the sun goes over and then goes down, and as it sets just north of west, similar effects occur. This particular ridge is very highlighted. It's the orientation in the exact opposite direction of the backstone, and it comes down. The other thing that occurs that night is that right as soon as it gets dark, it's like a snap, like it gets dark, and there is the Milky Way hovering literally over and joining the central points of the same ridges. In a similar way that we saw the Milky Way at the other sites, remember yesterday in the planetarium. I think the Milky Way is also significant here. And as you go through the night, it moves over and then it goes down over the western ridge. So all I've wanted to show you here really is what you can do with the horizon, how you can then put it into stellarium. Sorry, that was I put my 3D landscape into stellarium. And what I'm going to show you now is a video. Once I got the video ready, this is my last thing, and we can find the video. We need the lights out. Oh, sorry? Yep. Or not. You choose. About 1 minute. 1.5 minutes. And we need sound up. And we need to turn everything else off. That's not working.
Fold on your hands, give me a sigh, put on your lights, lay down next to me, don't listen when I scream, bury your doubts and fall asleep.
Going out of one region to the other.
Find out I was just a bad dream.
There goes the Milky Way. Can't see it on there, unfortunately. You can only see it on the screen. Oh, off we go again. There we go. So I hope I've showed you at least something today, the kinds of things that how you can use Horizon, you can practice yourself, put it into Stellarium, and then try and understand what it is people really saw when they were standing at their site at very particular times of the year in relation to the orientation of that monument. Thank you.
Thanks, Gail. That's fantastic. Okay, we are gonna break for lunch. 2 quick things. Number one, we put out a call for who's going to host the next Oxford meeting in 2028. So we haven't had anybody come forward so far with a proposal of who's going to host the next meeting in 3 years. Noting there have not been any Oxford meetings in either Asia or the Pacific. So if anybody's interested in that, start having a chat now, because we're going to be discussing proposals during the general meeting next Wednesday morning.
Mm-hmm.